What's up, calculus students? Unit 4, lesson 1, new homework. Kind of changed up the lesson, changed up the homework, make sure better prepares you for your test and for the types of questions that we see, where we are doing derivatives of E and A. We are essentially just reviewing all of Unit 2 and 3, just with E to the x, A to the x today, and then the natural log of x tomorrow. And E to the x is a very crazy function, a very interesting function. E being a number, it's important to know E is a number, 2.71828, that occurs naturally, like the numbers don't repeat, it's like changes. It occurs naturally with infinities, occurs a lot where it is the base of an exponent. And what's very interesting about it is that the slopes of E to the x are its own y values. So the derivative of E to the x is E to the x. This is the only function where this is the case. All of our other functions, we looked at x squared, its derivative is 2x. Every other function has a unique and different tangent slope generator. E to the x, it's itself. It's very confusing to students because this will generate slopes, this will generate y's, but they'll end up being the same. For example, we're asked to find the derivative at the point, so f prime at log 2. What's important about e's and logs undo each other. So log 2, e to the log 2 is just 2. E and log just undo each other, so I just get 2. However, if I plugged log 2 into f, I get the y-coordinate 2 as well. So my equation of my tangent line, if I was asking you for it, would be that. This is where the m and the y will be the same. It'll just be the same always. Throw these at you. It's very important. A lot of students have difficulties with these. Don't have difficulties of these. You don't use the quotient rule here. It's not x's divided by x's. This can be rewritten as 1/5 e to the x. It's just a constant. If you're taking the derivative, just leave the constant alone. Multiply by the derivative of e to the x. That's e to the x. Okay? So that is the slope generator of this. Now, I gave you a challenge here. What happens if you plug in 5 log 3? Well, you were told that e to the log 3 is 3, like e to the log 2 is 2. But what happens if we have a 5 here? Well, this is kind of confusing for a lot of students, but if I had, say, 2 times y here, if I had 4 to the 2y, we can use exponent properties similar to what we did with 8 to the 2/3, how we rewrote that as 8 to the 1/3 squared, because when you have a power to a power, you multiply. Well, if you have a multiplication, you can rewrite it as a power to a power. What I'm going to do here is rewrite this as e to the log 3 to the 5th power, giving me an answer. It's actually a little bit complicated. It's 3 to the 5th times 1/5. It's not that the 5 and the 1/5 are going to cancel. Don't love that example. I probably would have preferred it be this. So maybe I'm going to give you 2 points here, or I give you 3 log 4 or something like that. So I'm going to take the derivative and plug in 2 points. Now, here's where things get a little bit difficult. Heads up. We didn't have to use any crazy rules for these first two, and then we get to this one. And it looks like it's simple, just like the first two, but it's not. This is a chain. It's an O and an I. And we talked about this in class, how if we have different things other than just x in the exponent of e, we need to write it as an O and I, where the derivative of e to the power is e to the power, it's just itself, but you got to take the derivative of the power, or the derivative of the inside. So the derivative here is actually not going to be the same as the original equation. We'd get an extra 1/3 times, remember what starts in the parentheses stays in the parentheses. Again, either rewrite it as 1/3 times x or leave it as x/3. Now, if I plug in 0, let's just remember that anything to the 0 power is 1. So I'd have 1/3 times 1, which is 1/3. And then watch what I'm going to do here with 3 log 4. If I plug in 3 log 4, I can actually cancel this 3 and this 1/3, and it becomes a 1, which means it becomes e to the log 4, which is 4. 4 times a 1/3 is 4/3. So just two different answers. Messi, what is g double prime at 3? This is good. This is important to be able to do second derivatives. So this is my first derivative. If I were to take the derivative of that derivative, I would need to O and I it again. Now, that 1/3 in front is just a constant. You can not worry about it. It's not a product rule. It's not x's times x's. Constants can just get left alone or incorporated when we end up multiplying. So the derivative of our outside is 1/3 e to the power. Derivative of the inside is 1/3, the 1/3 x derivative. Okay. Now, remember the chain rule, you multiply your O and I's derivatives, and when you multiply, you can multiply your constants together. Maybe like not have to worry about writing it out too crazily. You get 1/9 e to the 1/3 x. At 3, I'll get 1/9 e to the first, e over 9. All right, now we get into our rules, like the product rule. We see x's times x's. The quotient rule, we see x's divided by x's. So we got to review the product rule and review the quotient rule. We got the derivative of the first times the second plus the derivative of the second. Yes, I did take the derivative. That's the derivative of e to the x. It's the only function that happens. Derivative times the second times the first. Plugging in 0, I get e to the 0 plus e to the 0 times 0. I get 1. Cool. Next one. Do you remember the quotient rule? It is the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. We then plug in 2. I get e squared times 3 minus e squared over 9. 3e squareds minus 1e squared are 2e squareds. You need to be able to combine amounts of things like we would with anything. So get e to the negative x. Okay. If in the power it's something other than just x, we need to O and I it. It's a chain. E to the power, its derivative is e to the power. The derivative of the inside, -1. We get e to the negative x times -1, or negative e to the negative x. If you want to multiply these together, maybe make it look nice, you put that there. Plugging in 1, I'd get negative e to the negative first. We need to be comfortable with negative powers being positive powers in a denominator. Now, what did I do? I kind of left the -1 up top. I just moved the e. If you wanted to write this as 1 over negative e, that's the same. Cool. Next, another product rule. Derivative of the first times the second plus. Notice I didn't distribute this first. That would just make it more complicated. A little bit. Plus the derivative of the second. The derivative of e to the x plus 1. Well, the derivative of 1 is 0. The derivative of e to the x is e to the x. I took the derivative of e to the x plus 1. It is e to the x. So the derivative of the second times the first. A lot of you will need to get comfortable with the fact that you're taking a derivative, but nothing happens. It's that's okay. Just know that you took the derivative. It's annoying. Okay. Plugging in 2. I get 4 e squared plus 1 plus e squared times 4, giving me 4e squared plus 4 plus another 4e squared. I would expect you to be able to simplify this to be 8e squared plus 4. Okay, more of the same. O's and I's. Derivative of e to the power is e to the power. Derivative of the power is 2x. This would be an O and I again. If you want to multiply those together, you get 2x e to the x squared. If you plug in -3, I'd get -6 e to the 9. O and I here, again, e to the power sine. Sine's derivative is cosine. E to the power's derivative is e to the power. Multiply, I'll have cos x times e to the what starts in the parentheses stays in parentheses. If I plug in pi, I get the cosine of pi, e to the sine of pi. Cosine of pi, let's see, 0 pi, cosine horizontal x. Cosine of pi is -1, sine of pi is 0. So I get -1 e to the 0, which is -1. Cool. Numbers to x's. The derivative of a number to the x is the number to the x times the natural log of the number. It's kind of easy to see this with e to the x. If you took the derivative of e to the x, you could say it's e to the x times the natural log of e. But we talked about how e's and logs undo each other. So e to the log something is the something. The log of e to the something is whatever that something is. The log of e to the first is just 1. So like we don't need this. There we go. H prime of a half would be 4 to the 1/2 times the natural log of 4. I'd expect you to know that the 1/2 power is a square root. We don't need a plus or minus because we're not using a square root to solve. We just get 2. Cool. The derivative of L is 2 to the x times the natural log of 2. L prime of 3 would be 2 cubed, ln 2. 2 cubed is 8. That would be the slope of 2 to the x of 3. If there's something in the power that is not just an x, you need to O and I. 4 to the power, its derivative would be 4 to the power times the natural log of 4. X over 4 is not a quotient. It is just 1/4 times x. It's just a constant times x whose derivative is the constant. It's like the derivative of 3x is 3. The derivative of 1/4 x is 1/4. The derivative of x over 4 is 1/4. Don't do this if x is in the denominator. That doesn't work. Probably should have had one of those. Just to like mess you up. I'll throw one in somewhere. Because that's good review too. What's the derivative of 4 over x? Darn. All right, multiply these together. Here's a problem. 4 is taken to this power, x over 4. You cannot multiply this 1/4 by this 4. Order of operations, exponents need to take care of itself first before you can multiply. So don't multiply the 1/4 and the 4. You can't do it. Plugging in 2, I get 1/4 times 4 to the 1/2 times the natural log of 4. 4 to the 1/2 is 2. So I get 1/2 log of 4 after multiplying the 2 and the 1/4. All right. I'm going to change one of the examples. 16 to the power. I gotta make a note. I'll make a note afterwards for next year to change the homework again so that I have some x over 4s and some 4 over x's kind of deals in the numerator, in the exponent. All right. 16 to the power natural log 16. I don't know why I wrote 14. Negative 2x. You cannot multiply the negative 2 and the 16, so don't. It's just negative 2x times 16 to the negative x squared times the natural log of 16. Now, if I plug in a half, let's see what happens. I get negative 1, 16 to the 1 half times 1 half, make it opposite, negative 1/4 times the natural log of 16. 16 to the negative 1/4. It's the same as 1 over 16 to the positive 1/4. I could take the 4th root of 16, 2, 4, 8, 16, and I get 2. So I did this on purpose so that we ended up with a 1/2. This is 1/2 times negative 1 is negative 1/2 log 16. Three to the 3 over x, changing it. Why did I put this example down? Because if you don't have a product, don't use the product rule. If you just have a sum, the original derivative is 3 to the x log 3. If you plug in 2, you get 4 plus 9 log 3. Now, with the change, that's the original derivative. What's the change? Let's call this a q. Q looks like this. Okay, q prime would be 2x plus. I got to O and I it. 3 to the power, whose derivative is 3 to the power natural log 3. And then 3 over x. Good one. You could use the quotient rule here. Or you could rewrite this as, I'm recording a video. Come later. Taking the derivative of 3 over x is 3x to the negative first. We get negative 3x to the negative second using the power rule. You would get that if you use the quotient rule. That means we got 3 to the 3 over x log 3 times negative 3 over x squared. Review. It's important to review all these things because Unit 3, we really just kind of stuck to polynomials, and the derivatives were very easily done. But now we're going to increase our difficulty, get back to our derivative rules. Now that we understand Unit 3, we can make it a little harder. Yo, I see x's times x's, and part of my left side is our power is negative x. That negative x power is not just x, which means you have to O and I it. So if I was to take the derivative of q, I would need O and I for the left part. I get negative 5e to the negative x, derivative of the first times the second, plus the derivative of the second times the first. Plugging in 0. Negative 5e to the 0, sine 0 is 0. Plus cos 0 is 1, 5e to the 0. So I get 5. Common question that we would ask is is the function increasing or decreasing? And you'd have to say, oh, the derivative at 0 is positive. The function is increasing. We don't have to do a full sign analysis, and we're going to get that later. All right, now we got equations of change. This is a long homework. Remember, this is the equation of the line. Slopes come from slope generators, comes from slope formulas, comes from G prime, F primes. Y's come from the original equation. Plug in x's, get y's into original equations. Plug in x's into derivatives, get m's. Don't forget that. You can write the 2x in front of the e to the x squared. Plugging in 3, e to the 9 times 6. So that's my m. Plug in x's, get m's. Plug in x's, get y's. Plug in 3 into the original equation. Get the y of the original equation. Plug in 3 into q prime. Get the m. This is e to the 9th. Don't multiply this 2 and this 3. Don't think it's a product rule because it's not x's times x's. Just take the derivative of the 3 to the x, which is 3 to the x log 3. Leave the constant 2. You can't multiply the 2 and the 3. Order of operations. This is not the same as 6 to the x. Don't think that it is. Plugging in 2, y minus the y coordinate. Plugging in 2, I'd get 9 times 2, which is 18. Plugging in 2, I get 9 to 18 log 3, x minus 2. Okay, let's go ahead and plug in 1/3 log 4 to start. We get e to the log 4, which is 4. The 3 and the 1/3 will cancel, make a 1. Boom. So I got y minus 4 equals, I'll find my m soon, x minus 1/3 log 4, or log 4 over 3. The derivative, you got to use an o and an I. E to a power 3x. The derivative of 3x is 3. The derivative of e to the power is e to the power. I get e to the power times 3. So that's e to the 3x times 3. If I plug in 1/3 log 4, I already got that. The 1/3 log 4 plugged in. The 1/3 cancels. You get, oops. E to the 3 times 1/3 log 4 times 3. These cancel. E to the log 4 is 4. 4 times 3 is 12. Product and chain, we kind of already know the derivative of e to the 3x is e to 3x times 3. So like, I'm not going to show the o and I step again. Derivative of the first times the second, plus the derivative of the second times the first. Plugging in 2, I get 4 e to the 6 plus 12 e to the 6, 3 times 4, giving me 16 e to the 6. If I plug in 2 into h, I get 4 e to the 6. So I got y minus my y equals my m, x minus 2. Cool. More unit 2, table problems. What if we have notation with f's or g's or something like that? And I want you to take the derivative. And we're trying to find the value. Well, the exponent of e is not just x. Here, the exponent of e is f of x. The derivative of f of x is f prime of x. The derivative of e to the power is e to the power. The derivative of e to the f is e to the f times f prime. If I plugged in 2, I get e to the f of 2 times f prime of 2. This is where we go to the table. F of 2 is 0. F prime of 2 is negative 2. I'd get e to the 0 times negative 2. The answer is negative 2. That's the answer I'd want you to get. What if it's f of x times e to the x? Well, this is x's times x's. Now remember, the derivative of f is f prime. We don't have to o and I it, even though you see parentheses, because like the inside is just x, whose derivative is just 1. So I'm just going to use the product rule. The derivative of f of x times e to the x plus the derivative of e to the x times f of x. Plugging in 1, I get f prime of 1, which is negative 1, e to the first plus e to the first, f of 1 is 3. So I get negative 1 e's plus 3 e's, not e cubed, just 3 e's, and I get 2 e's. Take the derivative, use the quotient rule, the derivative of the top times the bottom, plus, minus, hope I didn't mess up earlier, minus the derivative of the bottom times the top, all over the bottom squared. E to the x squared is the same as e to the 2x, power to a power. You can multiply the powers. Plugging in 3, it becomes e to the 6. So f prime of 3 is negative 3, e to the x minus f of 3 is 2 e to the x over e to the 6th. I get negative, not e to the x, e cubed. Get negative 5e cubed over e to the 6th. We can simplify this. 3 of these e's will cancel with 3 of these e's, giving me negative 5 over e cubed. It's a good question, good simplification, good exponent rules. This is the combination of a product and a chain. The derivative of the first times the second. Plus, we already took the derivative of e to the f of x. It's e to the f of x times f prime of x times x. If I plugged in 2, I get e to the f of 2. F of 2 is 0. Plus e to the f of 2 times f prime of 2, negative 2 times 2. Giving me 1 plus negative 4, which the answer is negative 3. It's a good question. Okay, that was all Unit 2 review. Great. All of our rules. Table problems. Higher order derivatives. Took 1 second derivative. Great. Now Unit 3. Increasing, decreasing, concave up, concave down, maxes and mins. Curve sketching. Human graphing calculator. Is a function increasing or decreasing? Well, very, very important, first of all, to understand that you're just talking about one location. Now, if I asked you when f is increasing or decreasing, you would need to do a full sign analysis, a full step 1 and step 2. Since I'm just asking you at a point, all you have to remember is like at your test point 1, if it's positive, you know f prime is positive, f must be increasing. If f prime is negative, that means it's got to be decreasing. So we don't need a full sign analysis if you're just looking at one point. Remember, the interpretation of a derivative is at this location, this function is increasing or decreasing, this many y's per x. Based on the sign, we say increasing or decreasing. All right, so let's get into it. X's times x's, I need to use the product rule, and e to the negative 3x, we've done it. Make sure you know how to do it. The derivative is e to the negative 3x times the derivative of the inside, which is negative 3. So that's the derivative of the first times the second, minus plus the derivative of the second times the first. Now, a lot of people are like, well, I don't know if this is positive or negative, and I don't want to do a sign analysis. We could do a sign analysis, but let's just plug in 1 and see what happens. I get e to the negative third times negative 3 times negative 3 plus 2 times e to the negative third. Okay. I get positive 9 e to the negative third plus positive 2 e to the negative third. That is 11 e to the negative thirds, which is the same as 11 over e cubed. What's very, very important is that e to any power is always going to be positive. Take an exponent, no matter whether it's positive or it's negative or it's 0, you will get a positive number. This is important. That means this is positive. It's greater than 0. F prime of 1 is positive. Since f prime of 1 is positive, f is increasing. 11 over e cubed y's per x. At x equals 1. Let's check this one out. Same deal. We have to use the product rule, but the derivative of e to the negative x is e to the negative x times -1. So that's the derivative of the first times the second, plus the derivative of the second times the first. Going to plug in pi over 3. Now, in this situation, it might be easiest, and we'll do this a lot later, to factor out the e to the power from both terms. This is what we're going to do when we do a sign analysis and we have e's involved in it. Factor it out. This is always positive. I get negative sine x plus cos x. Okay. If I plug in pi over 3, again, this I know is positive. E to any power is positive. That's all you got to know. Now, the sine of pi over 3 is root 3 over 2. So this is negative root 3 over 2. The cosine of pi over 3 is 1/2. What is negative root 3 over 2 plus 1/2? Is it a positive or a negative? That's very important to kind of think about. Well, it's like got the same denominator, so if you wanted to, you could say -3 plus 1 over 2. How does root 3 compare to 1? Well, I know root 3 is between 1 and 2. It's probably closer to 2 because I know root 4 is 2. I know root 1 is 1. So we're probably thinking about like it's around 1.7. Negative 1.7 halves plus 1/2 is going to be a negative value. So like you see this on your quiz and on your test. Boom, that's a negative. Positive times a negative is a negative. We're decreasing. And by this many y's per x, whatever that value is. All right, now let's do some function analysis. Unit 3, relative extrema is our first derivative sign analysis. Man, if you failed your test, it's because you forgot there's like 2 different analyses. I swear. So many people like forgot that there was a first derivative sign analysis which told you something. And then there was a whole different second derivative analysis that told you something. You don't just do one thing and it tells you both. Like f prime tells us f increasing or decreasing. F double prime tells us f prime increasing, decreasing. F's curving. Anyways, we just need our first derivative sign analysis. So we just need our like step 2. The derivative of the first times the second plus the derivative of the second times the first. Ready, set. How am I going to set this equal to 0? Factor out the e to the x. It is a common theme when we're doing sign analysis of things with e's in it. E to the x will never equal 0. It's impossible. You can like think about plugging in negative infinity and you're still approaching 0. Because it's like 1 over e to the positive infinity. You're approaching 0, but you don't equal 0. So like you could just chalk this up to this being positive. You can almost forget about it. Don't want you to forget about it, but you could. You get 0 and -2 are your zeros of f prime. You get positives and then sign changes. F has a max at -2 and a min at 0. Cool. This is a fun one. We kind of did this. Here's your product rule. The derivative of e to the negative x is e to the negative x times -1. So the derivative I can write as -4 e to the negative x. That's the derivative of the first times the second. Plus the derivative of the second times the first. How do I set this equal to 0? What am I going to do? Well, factor out the 4 e to the negative x. If you want to factor out a -1, great. This is always positive. Forget about it. We just need to figure out when sine x and cos x plus cos x equals 0. Well, this is the whole idea of like subtract cos x, divide cos x. It ends up tan x equals 1, or when does sine and cosine equal the same value? That's going to be at pi over 4 and 5 pi over 4. Cool. I should have put a stipulation that this was between 0 and 2 pi because I don't want to go beyond it. Test points. Again, this is always positive. We only have to check what's going on here. If I plug in 0, 0 cosine 0 is 1. So this is going to be a positive. I plugged in pi over 2. Sine of pi over 2 is 1 times a negative 1. That'd be a negative. Cosine of pi over 2 is 0. So this is a negative. If I plugged in 3 pi over 2 or 2 pi, cosine of 2 pi is 1. Sine of 2 pi is 0. So this is back to being positive. So I'd say x equals pi over 4 is a max because f goes up then down. X equals 5 pi over 4 is a min. Derivative of the first times the second plus the derivative of the second times the first. What do I do now? Factor out the e to the x. What do I do now? Oh, I'll probably rewrite this as x squared plus 2x minus 4. What do I do now? Give up. I should probably change this to something that can be factored. Two numbers that multiply to get 4 and add to get 2. Don't work. How does this work? We need kind of like 2x. Two numbers that add to get 2. Can't be 2. I mean 3 and 1. Then that would have to be 3. All right. Change it. It's all right. You probably got to this and you're like, what do I do here? Use the quadratic formula? I won't do that to you. I'll give you problems where it is factorable. There we go. So I would write this as x plus 3x minus 1. Sign analysis. Negative 3, 1, positive, negative, positive, f prime. F goes up, goes down, goes up. X equals negative 3 is a max. X equals 1 is a min. All right, another fun one. Derivative of the first times the second. Plus the derivative of the second. Oh, and I, if you're not sure, do it. E to the power. The derivative of negative x squared is negative 2x. The derivative of e to the power is e to the power. So I get e to the negative x squared times negative 2x times 2x. What do I do now? Factor out the e to the power. You get 2 plus negative 4x squared. Now, I can solve this for sure. We're going to have to do an equation where we're solving. Subtract 2 divided by 4, you get x squared equals a half. You get x equals plus or minus root a half. Square root of a half is the same as square root of 1 over the square root of 2, which is the same as 1 over root 2, which is the same as root 2 over 2. Just make sure you guys know that. This is the same as root 2 over 2. All right, if I were to do a sign analysis, again, I don't really care. If you write it as root 1/2 or root 2 over 2, they're the same. If I plugged in something like 0, I see I get a positive. If I plugged in something like 5, I could see this would be bigger than that, so that'd be a negative. If I plugged in something like negative 5, then we'd get a negative as well. That means we have a min. Grabbing your quiz?
Sorry?
Are you grabbing your quiz?
No. It's my quiz.
Somebody
Because
graded it wrong?
Yes, I think it's a -0.
Okay, let's check.
It's in the other thing.
All right, they just didn't look in order there. Yeah, it's fine. I'll fix it.
Okay, thank
Do
you.
you need it?
No.
Okay. We'll see you later.
See you later.
So x equals negative root 2 over 2 is a min. X equals root 2 over 2 is a max. If I want to look at my second derivative sign analysis as well as my first, we have to be careful. Derivative of the first times the second plus the derivative of the second times the first. Factor out the e to the x is probably preferred before you take the second derivative. So I'm like going to do all my work with this first one. I get e to the x times 2x plus 3. I like that. I get x equals negative 3 halves, setting this equal to 0. Again, this is always positive. It's that guy. My second derivative, let's do my second derivative. I would go off of this simplified first derivative. You could go off of your simplified first derivative. It's just like a little bit more going on. Derivative of the first times the second plus the derivative of the second times the first. Factoring out an e to the x, we end up with 2x plus 5. That's my second derivative. And I end up with negative 5 halves. Okay? It's not that bad, but you got to be able to do it, and you must do it yourself. You need to practice this. Make sure you list off that f prime, the negative 3 halves, to the right of the f double prime, negative 5 halves. I'm not going to put them on top of each other. I'm going to make sure things are in line. If this is negative 3 halves, then this needs to be negative 5 halves. Make sure you understand this is your 0 for f prime. Make sure you're doing two separate analyses. We just talked about maxes and mins, but now we're talking about concavity as well. Make sure you do your sign analysis correctly. Make sure you plug into f prime. It's simplified. If I plugged in 0, again, this is always positive, so we don't have to worry about it. We just worry about this. We'd have positives, negatives. Second derivative, same thing, positives, negatives. Increasing concave down, never. Decreasing concave up, sometimes. What's up?
Are you in video?
Yeah.
I'm in the video. Hi, guys.
Shout out, Sahota.
I love my cat. Is this my cat?
What up, Shoddy?
Thank you.
How is the career fair there, guys, or the college fair? Where are you going next year? ACC. Hey, I'm gonna push my kids to go to ACC so they can prove that they can do well in college, and then I'll send them to a real college. It's like a nice intermediary step. Can you live on your own and do well? Okay, now you can go to a good school.
There's more free stuff that I can get. Like,
There wasn't like food or anything.
yeah.
There wasn't like pens or anything?
Yeah, no pens, no buttons, no stickers.
All right.
All right, well,
Last two problems, guys. Here we go. Decreasing concave up. Derivative first times second plus derivative second times the first. Yeah. There's f prime. Let's do f double prime. Derivative first times the second plus derivative second times the first. Factor out. Would you look at that? Might have to look at this. Oh, okay. I get 2x minus 1 plus 2, which is 2x plus 1. It'll be fun to look at this. I'm going to look at it on Desmo. It's like, you guys don't appreciate it, but I do. First derivative, second derivative, sign analysis. First derivative, second derivative, sign analysis. Positive 1/2 for my first derivative. Negative 1/2 for my second derivative. Positives and negatives, positives and negatives. Decreasing concave up. This is when f is decreasing. This is when f prime is increasing, which means f is concave up. Negative 1/2 to 1/2. Let's go ahead and see this. Actually, we'll look at them. We'll look at them later. Last one. Derivative of the first times the second plus derivative of the second times the first. Factor out an e to the x. Set it equal to 0. Got that. Second derivative. Let's go off of this just so you see what it looks like. It's the derivative of e to the x plus the derivative of e to the x times x, which means like just take the derivative of e to the x. Now use the product rule for this. Derivative of the first times the second plus the derivative of the second times the first. If you factor out e to the x here, you'll have a 1 left over here, an x left over here, and another 1 left over here. If you did this a different way, like off of this, you get the same thing. You get an e to the x times 1 plus x plus 1 times e to the x. Just whenever you factor out e to the x, make sure you leave 1s there. So I get -1 for f prime and -2 for f double prime. I'll probably change it up on your quiz. So like one of these is negative. So like the signs are flipped. Don't just always assume things are going to work out this way. Like do your analysis. Make sure you understand. When is f increasing concave down? Never. It's never. Why do I keep asking that? It's increasing concave up from -1 to infinity. It's decreasing concave up from -2 to -1. But it is never increasing concave down. That's, I mean, good. It's good to know. Let's look at them really quick. Let's just look at this one. Two x minus 3 e to the x. Oh, sick. Decreasing concave down until -1/2. Boom. There's my point of inflection. If you zoomed in, you can kind of see it like right there. We change our curvature from concave down to concave up. Boom. Okay. Now, from -1/2 to +1/2, we are decreasing concave up. So right from here, we're changing our curvature to concave up, just barely, until we get right there to 1/2. There's our minimum location at 1/2. Point of inflection, minimum. From there on, we are increasing concave up. It's pretty cool. We could do that analysis just from our friend the derivatives inside analysis. All right, I'm out. Have a good one.